Greetings, fellow time travelers, and everyone still stuck on Earth. This is another LinuxCollections.com how-to video for your education, information, and entertainment. Let's get rolling. Today's video is an introduction to GUI development with several examples of code that interfaces with the graphical user interface. We'll start with some coding basics for new developers and then walk through the examples and cover the development requirements so you can build and run these examples. This started with a Facebook request, so don't forget to subscribe and let us know what else you might like to see. For people new to Linux, you may want to look at some of our other videos, including the intro to the command line, bash scripts, and the Debian install walkthrough that we're going to blur through. So we'll blur through the install and the development system setup and get right into the code. Our blog and video links at LinuxCollections.com, you can find the code and notes so you can learn and play around with this example at your own pace. This video is a quick overview of how to get going and good things to know. So we'll start by booting up our LinuxCollections.com Debian USB Developers Collection, and we'll select the install option, and then we will just walk through, and when we get to the selection of desktop environments, we are simply going to select them all. So we'll be able to test on this system all of the various desktop environments with our graphical user interface programs. When you get to the selection of the display manager, you can select any of these, but we'll go with the SDDM, which is the one that the KDE environment uses. After the install, you'll see that we have the option of selecting any of these desktop environments as an option before we log in. And this gives us a way to easily log out, log in, and go to a different environment. For our purposes, we're going to run the KDE Plasma Wayland version. Finally, once we get installed, we're going to do a couple of steps, and this is outlined in the readme.txt as part of the code and notes. This is detailed in the notes, but conceptually what we're going to do is we're going to make a directory, copy all the ISO files into it. The one advantage of this approach is you do not need internet access, and it'll be the fastest way to get these packages installed. So let's get started by downloading the zip file that has our intro GUI dev files with the readme.txt, source code, and build script. So we hop out to the LinuxCollections.com, go to our blog site. You might have to search for that if we've added other items, and we download it. So this will end up in our downloads folder, so let's go check it out. And there it is. So what we want to do is we're going to move this down to the root folder, our home folder here, and unzip it, and this will go into a code subfolder. So you can also drop it wherever you want, under documents or your own private folder. And let's go and open the readme.txt. You will want to spend some time on this and review it, go through it just to see what we're talking about. But for our purposes, we're going to just get right into it. So to begin with, we want to copy the mount opt ISO as the super user or the root user so that we have access to all the packages. So the mount opt iso.sh or shell script is just a script that will mount all the ISO files and then add it to the apt system to access all our packages. So let's begin with code. We, for new developers, are going to talk a bit about hello.c, the basic hello world approach. So we point out three important things. One, every program in C has a way to access external functions. That's our system glue or system interface. The main is the entry point, and then our function printf, which is a way to echo to the console. So now let's jump into the terminal or the console, and we'll beef up the font size, and let's look at what we've got. So we've got some build scripts, some .c source files, and some the readme text, etc. So let's look at the build script. Here we just have a basic bash script with a comment that's called build script, echo begin, and then we have the main line, the gcc, the -o hello world, which is our output file, and then we have the source file. So let's go ahead and run that script and build. So we get the begin, we say hello is built, we look and we now have a new file, hello world. Let's run it. There it is, hello world. It puts out hello world. We're programmers, woohoo! Let's quickly cover another few things. One is if you do gcc with the help, you get all the options. We're actually going to look at the compile only and the preprocessor. That's the -e and the -s capitals. So let's look at that. If we do the gcc -e, we will pre-process this file. And what the heck does that mean? Well, let's go look at hello.pre, which we just put the output to, and we can also run the compile only, and we'll see we have a hello.pre, and then there's this hello.s. So we'll jump back into the text editor, and this is the preprocessor. And again, this is something you can play with and look at, but this is what happens when you pre-process a file. It breaks it down into C code and comments, and it's huge. Look at the size of this file. It is gigantic. And this is all from putting those pound includes, the standard I/O for input/output, and the standard lib for standard library. And at the very, very bottom, we have our source code. So that's what the preprocessor. It's a two-step process. We process it, and then we compile it. So all that stuff up above there is the preprocessor code that gets generated. So that's everyone that doesn't understand the compiler should at least grasp what's going on, and that's why I wanted to show that. And then finally, if you compile to the assembler, which is the next human readable machine code, this is where you actually see the simple commands that are done from our source code. The other libraries that get linked in are at the linker phase. We're not going to spend any time on that today. So let's close down these other files and get into, while we're here, the Introduction to Graphical User Interface Development. We're going to open the hellox.c file, zoom up the font a bit. Now we could spend days going through all this code and all the details. The purpose of this video is to get you started. These have all been extensively commented. You'll notice there's many more pound include files at the top. There are global variables. Here's our main where we enter. There are new structures and variables that start with an X, function calls that start with an X. And these are all part of the XLib or XWindows Application Programming Interface, or API. Many, many details here to go through, but you can see we create a window, we add some properties, some size hints, some other window manager properties. We then do some font work, and we now create a graphical context. All these details are there to learn, but we can't spend the time right now to go into it. Finally, we map the window onto the screen, and we fall into an event loop, or the loop that waits for server or user generated messages. We capture several of these where the button or key press, we will shut things down and exit. So let's go look at the build X script. So to begin with, we want to see what's going on here. Well, it looks pretty much the same. So let's try to run it. We run /buildx. Uh-oh, we've got trouble. There's a fatal error. X11 xlib.h is not found, and our compile has terminated. So this is what prompted the request for this video. You download an example, you think it's pretty cool, you try to run it, and you don't have the development libraries or tools to run it. What's going on? How do you solve this problem? Well, the first step, of course, is to reference any text or details that came with the example. And we'll also look at some other options you can do to find headers or libraries, that kind of thing. Developer documentation can be a haphazard type of thing, so you do want to kind of investigate whatever your example is. It could be in the build scripts, a make file, and the RTFM acronym is for Read the Find Manual. If the information's there, asking someone about it means you didn't take the time to investigate. So if we look at our build script, it actually has this cryptic comment, apt-get install lib x11-dev. That is what we need. And it turns out if we go and look at the readme.txt, which we of course have read, it talks about that you need to install this to get the headers and libraries for the X11 build. One tool that can help you find packages is Synaptic. This is the GUI interface, and you can access and find things such as headers and details by getting into this with your super user root password. One of the options in Synaptic is the search. Because our x11.h file failed us, let's start with that. We search on that and find out there's no results. Well, what was that? Well, that was a header file, so let's try x11 header. And now we've got a bunch of things. And here we, of course, have to take the time and step through them and try to find out what's what. Obviously, knowing exactly what package you need is helpful. In this case, the development headers are in the libx11-dev install package from Debian. We can, of course, install this from the Synaptic, but we're going to just jump down to the command line and do it with our apt-get install libx11-dev as the super user, and we'll walk through this install, zoom through it, and now we've got our X11 libraries and headers installed. So now if we do the build X script, Uh-oh, new troubles. What's going on here? Well, all these undefined references means that those header files are looking for the library object code that doesn't exist. Now, the way to solve this problem is to actually specify a library on the command line. So let's look at our build X script, and an astute observer will notice that we've actually snuck in a new line here, and this has the -LX11. So what we're going to do is quickly edit this, comment out the original line, and put in the one that has the library X11. Now when we build our script, we'll notice that it builds. And if we look at what we've got, a new file, Hello World X. And here we go. Now we have an XLib based GUI window that's running in our graphical user interface. With the XLib based window, you have the window manager that provides the title bar, sizing edges, etc., based on the hints and properties we set in the example code. Now there is one joke that goes, there's only been one Windows program ever written. Every other one beyond that was a copy of the first one. Why reinvent the wheel? What you can do is take this as a template and modify it as needed. You can add your own drawing code, how to handle the user interface, what to display, and so on. So now you have the framework to get a window on the screen, and away you go. Now let's look at the GTK example, or the GIMP toolkit, or GNOME toolkit. This is a complete environment. We're going to look at Hello World GTK. It talks about packages that need to be installed, talks about what's involved with getting all the headers and libraries, using the tool package.conf, and it's a pretty tight example using the GTK API. You create an application, you connect to the server, you create a window, you do the window actions, create a button, and you have an event that fires, and that types hello world using the gprint. So all we have to do now is build it. So let's run build GTK. Uh-oh, what is going on? Well, guess what? We didn't do the step that added those packages. So we need to add package.conf and the libgtk tools. We're going to zoom through that, and then we'll look at the package config and how it actually pulls out all the include files and the libraries as a separate section in the GCC command line. So if we look at the build GTK script, we'll see that there's this $ with parentheses for the package config C flags, or --C flags, GTK4, and then further on we have the libraries, or package config --libs GTK4. And what that actually does is and you can see this, we actually pulled this out and put it in that Hello World GTK, something to go look at. There's a ton of includes and libraries. So now we can build the GTK example. So after it's built, we can look at the files and find out that we have a brand new file, Hello World GTK. So we can run Hello World GTK, and now we've got a window, and it actually has an embedded button. That whole middle part is a button. When you click on the button, it types out Hello World. And that's our little GTK example. Now we'll summarize this at the end, but let's jump into a Wayland example. As of today, Wayland looks like the future, replacing the X server and the XLib environments that have been around since the 1980s. But note that the X on Wayland exists, which provides a compatibility layer for X window-based programs. The Hello Wayland.c source example is several examples merged together. It's fully documented, and as we scroll through it, you're going to see just how complicated and in-depth the Wayland protocol and operation is. We have to register interfaces, we have to handle pointer events, we have to handle window events. For the display, we have to deal with buffers and shared memory. For the fonts, we have to render them all ourselves using other tools. This example only handles a few interfaces, but we've listed a bunch of them to see just how many there are. Finally, we get into the main section of the program, or the entry point, and you'll see that we do some basic things. We connect to this display, we register our interfaces, we create a surface, a compositor surface, and then we fall into an event loop similar to our other examples. So let's go in and see what the build Wayland script looks like. So as we type out the build Wayland script, you'll see that we have the apt-get install live Wayland. So we go ahead and do that. It turns out it's already installed. When we did that GTK stuff, it installed those libraries. So we don't even need to mess around. We can build Wayland, and then we can go ahead and look at our files. We see a new Hello Wayland. We go ahead and run that, and voila, we've got a new display window as well as a cursor that says Hello World. Note there are no window decorations. That's a whole nother aspect to Wayland that we aren't going to get involved with today. So that wraps up our quick introduction to GUI development. We started with a general overview of basic development concepts, including the preprocessor, include files, libraries, and package management tools to access the files needed to build specific targets. We walked through three big examples: the xlib or xwindow system, an example using the GTK API, and an example using low-level Wayland API calls. The reason you may select GTK or Qt, which we did not go in today, is to wrap up some of these low-level API calls and utilize existing libraries of code, depending on what you are trying to accomplish. A critical aspect of any development. Being tied into a fixed approach may not be what you want. Perhaps you want low-level API calls. Perhaps you don't want to require GTK or Qt libraries as a requirement. Perhaps you want to rework some already existing open source code, and so on. As noted, these source code files are fully commented and give you a great starting point to begin your expedition into developing for the graphical user interface in Linux. So thanks for joining us on this journey. This is LinuxCollections.com signing off.